this is for methods pathways. We're going to look at exercise 4.5, question 4 and 5. So it's 4 and 5 asks us to factorize the following expressions by completing the square, and the other one using the appropriate method. So we'll do the completing the square first, because I've got 4a, and I've got 2x squared minus 6x minus 1, and I want to factorize that by completing the square. First of all, you need to take the factor of 2 out first, because you cannot complete the square ever when there's a number that's not 1 in front of the x squared. Okay, so minus a half. What I do now is I do the scaffold here inside to double brackets. Half of -3 is -3 over 2. -3 over 2 squared is 9 over 4 minus a half. I combine the fractions together, and this is always the difficult part. -9 over 4, so you want both fractions to be over 4. Negative a half is the same as -2 over 4, so -2 minus 9 is -11 over 4. Now, use dots here. So different 2 squares, factorize that. So minus 3 over 2, minus root 11 over 2, x minus 3 over 2, plus root 11 over 2. And you're done. Okay. Now, let's do an example of I. So this is A. We'll do an example of I. So for I, we've got 3x squared minus 6x plus 5. And we want to use the scaffold, but I need to take a factor of 3 out first. Okay, so minus 2x plus 5 over 3. I want to factorize that, or use scaffold. So that's -1. Square root of 1 is 1, and then we've got plus 5 over 3 at the bottom. So we've got 3x minus 1, double brackets, minus 1 plus 5 over 3 is the same as -3 over 3 plus 5 over 3, which is positive 2 over 3. You can't go any further, you stop, because can you see there's a plus here? Normally we have to use dots, and dot stands for difference of 2 squares, not sum of 2 squares, so you cannot factorize this any further. If I try cross method, it won't work either. So if I go 3x and x for the original equation, you've got 5 and 1 and 1 and 5. It's not going to give you what you want, okay? Because you've got 1 and 5. 1 and 5. No, 1 and 3 and 5 won't work. 15 and 1 won't work. So we've run out of methods. We literally cannot factorize I. So some questions we cannot factorize, which actually makes sense when we get into the chapter of graphing. So let's have a look at question 5. We'll do H and N, I believe. So for H, we can try the cross method to see if anything works. So you find the factors of 2x squared, which is 2x and x, and possible factors of 4, which is 4, 1, 1, 4, 2, 2. Try each one whether it can possibly give us a 3. 2 and 4 will never give you a 3. 8 and 1 will never give you a 3. 4 and 2 will never give you a 3. So cross method is no go for this one, so you have to complete the square. So I'm going to complete the square for H, so 2H. 2x squared plus 3x minus 4. I take a factor of 2 out. 3 over 2x minus 2. I do the scaffold. That's positive 3 over 4. Half of 3 halves is 3/4. Then I square that, so it's 9 over 16 minus 2. Drop minus 2. Simplify the fraction. So we get x plus 3 over 4 squared. Now that's we want this to be both over 16, so 2 is the same as 32 over 16. 32 minus 9 is minus 41 over 16. So I then use dots, because there's a minus in between, that's great. So we've got x plus 3 over 4 minus root 41 over 4, x plus 3 over 4 plus root 41 over 4. And you're done, okay? For n, let's say cross product works. Okay, you always try to do cross product because that's slightly easier than having to do full-blown complete square. 3, 1, 1, 3. Will that ever give us 20? 4 times 3 is 12, 12 and 1. No, it's not going to give me 20. Let's try 2x and 2x. 1, 3, 3, 1. No, it's not giving me 20 at all. So cross method's no go. I need to complete the square. So I'll do it over here, running out of space. First step is I want to take the factor 4 out. So I've got 4x squared plus 5x minus 3 over 4. I do scaffold. So we've got x, half of 5 is 5 over 2. 5 over 2 squared is 25 over 4. And we're subtracting 3 over 4. Okay, the fractions are good because we've got something that's nice. So we've got 4 brackets x plus 5 over 2 squared minus 28 over 4. Use dots. So we got 4x plus 5 over 2 plus root 28 over 2 x plus 5 over 2 minus root 28 over 2. I'm using dots, by the way. Okay. Now, I'm not sure whether the book simplifies this, but root 28 on 2 as a surd is the same as 7 on 4, right? Well, I mean, root 28 is the same as root 7 times root 4. If you take the 4 out, you get 2 root 7. So I'm not sure if the book actually does this, but you got to make sure that you simplify that surd to being 2 root 7 on 2, x plus 5 over 2 minus 2 root 7 on 2. Okay, when you combine them, you get 4. Oh, maybe you don't need to combine them, so you just leave it that form. Okay, so that's basically how you approach these type of questions. You're just using scaffolding a lot, and these questions are more nasty in that you have a lot of fractions, so you got to be able to deal with fractions like these. So hopefully that helps.